What happens if you drive current through resistors that are in parallel? Meaning, if I have two resistors, I'm going to draw them as a kind of a physical resistor, and I have wires connecting the inputs to some current, which means then the current would come out of them. Okay. And so some current goes this way. We'll call that I1. That's going to be across R1. And some current goes this way. Call it I2. And across R2. And so our thought is to say, well, what is the equivalent resistance? If I put a black box around this and I didn't know that there were two resistors, I'm just measuring the current flowing through this system, what would be the equivalent resistance of these two resistors that are side by side or in parallel? Okay, well, the idea is to think that this current is equal to, by Ohm's law, the potential difference across those things, divided by that equivalent resistance. V equals IR, or we could say I equals delta V over R. Okay, so with that in mind, we just need to think, well, by the law of conservation of charge, this current must be equal to the sum of these two. So that's going to be equal to I1 plus I2, but each individually is equal to the delta V1 over R1 plus the delta V2 over R2. Okay? So we have a way of relating the total potential difference over the equivalent resistance to the individual potential differences and the individual resistances. But the definition of being in parallel is that the potential difference is the same, and therefore the same as this one. The potential difference from here to here or to here is 0. These are all at the same potential because this is one connecting wire. Even though there's a junction, that doesn't matter. It's all one piece of metal that connects all those 3 points. So all these 3 points are the same potential. Same thing can be said around these 3 points, which means that the potential difference across the whole thing, this delta V, is equal to the potential difference across R1, which is equal to the potential difference across R2. So we don't have a delta V1 and a delta V2, we just have delta V. This is delta V over R equivalent equals delta V over R1 plus delta V over R2. Since those are all the same, cancel that out, and we end up with a rule of reciprocals. Basically, 1 over R equivalent equals 1 over R1 plus 1 over R2. And I'm going to keep adding. This could have gone on if we had 3 in parallel. 1 over R3 plus ... It's true for any number that are in parallel. The argument would still hold. Okay, so this is our rule of reciprocals. Now, just to make sure mathematically, when you plug in the 1 over plus 1 over, you get 1 over R equivalent. So truly to find R equivalent by itself, you need to remember to invert the whole thing. Like that. Okay. And also, you need to be very careful not to make an algebraic mistake that is common of assuming that 1 over R1 plus 1 over R2 equaling 1 over R equivalent is the same thing as saying R equivalent equals R1 plus R2. Okay, that's not true. That is not true. This does not equal R equivalent equals R1 plus R2 plus ... Okay? Since these are in denominators, we have to treat this sum separately. We can do some playing around if we want to, but we've got to do our proper algebra to see if we can simplify this. But don't just, don't accidentally just try and add those denominators together.